Hello guys, this is the recording for the asynchronous session. Is the topic 1.5 component method for vector addition. In other words, adding vectors. And when we are adding vectors, we need to consider the direction and the magnitude of both vectors. In this case, vector A to B is the vector A, and from B to C, the green vector. If we want to get the addition or the sum of these two vectors, we need to consider the magnitude and the direction in order to get the resultant vector that in this case is the purple one. We will use the analytical method to add them, and it is called component method, and it contains the following steps. Step number 1, transform polar to rectangular coordinates. You may remember that from these formulas that we saw yesterday. And also, well, the step number 2 is to obtain the summation of x and y components. As I briefly mentioned in the class, these are summatories, and in this case, what it means is that you need to add all the x components of the vector 1, x component of the vector 2, x component of the vector number 3, and so on. And the same goes for the y component summation. You need to add the y component of the vector 1, y component of the vector 2, y component of the vector 3, and so on. So during this session, I'm going to be solving, the step number 3 is the summa, is that you need to consider the summations of the vector x and the vector y's of each vector, the component, of vector x component and y component of the vectors, and use them as rectangular coordinates of the resultant vector. And then we will use the Pythagorean theorem and the tangent function to get the result as a polar vector or as a polar coordinate. And in this case, the only difference is that instead of using Vx and Vy, you will use summatory of the Vx and summatory of the Vy, summatory of the y and x components. And for the direction, once again, we will use this formula, but also using the reference angles. Those are, depending on the quadrant, 1, 2, 3, 4. You need to use different reference angles. For quadrant 1, 0 degrees. For quadrant 2 and 3, 180 degrees. And finally, for quadrant number 4, it's 360 degrees. And then you need to add the result of this operation. Oh, another thing that is important to consider is that sometimes you need you will have different letters. You will have, instead of a B, an F if it's force, an A if it's acceleration, or W if it's weight. So let's see the example 1.4, and we will find the resultant force of this system. We have three different forces, and it is wrong. It should be force 1, force 2, and force 3. So I'm going to do the correction right now, and force number 3. Okay, so I'm going to use this table to make the operations. So we have the forces and the angles, and we need to calculate the x component of each force and the y component of each force. In order to do that, you need to multiply the vector or the force times the cosine of the angle. And for the y component, it should be times sine of the angle. Sine of the angle, right? So please stop the video here and try to calculate those numbers. I will be writing this here and try to get the results for each of those cells in the table. Okay, now we need to do the summatories. The summatories, well, these are the answers. Please check if you have the same. And then you need to do the summatories or the summations. And this is adding these three x components to get the summatory of the x component, and then add the three y components to get the summatory of the y component. And please pause the video here and check if you have the same answer. For the x component and the y component summations, we have these values. So right now, you have that the summatory or the summation of the x components of all these three vectors, it's equal to minus 53.3 newtons because it's the original unit. And for the y component of this force, the summatory of all the y components, we have positive 72.1. So let's continue to the next thing. We have completed the step number 1, that is calculating the x components. And these are the values, once again, for the summatory of x components of these forces, minus 53.3. For the summatory of the y component of the forces, positive 72.1. But then I think that with this information you can predict or estimate the quadrant. Remember, x is positive, y is negative. So in what quadrant is this vector? If is this resultant vector? Pause the video here and try to answer. And additionally, here are the formulas, and the quadrant, if it's negative on the x-axis and positive on the y-axis, it should be on the second quadrant. So let's see if we have a vector there. Here, for the resultant vector, you only need to substitute the values and perform the operation. So please pause the video here and check your result, or do the operation and get your result. And now, do you have the same answer? Check if you have the same, and then we will continue with the next part. In the next part is about the direction. So you need to substitute the values like this. Inverse tangent of 72.1 divided by negative 53.3. This is the inverse tangent of the summatory of the y components divided by the summatory of summations of the x components of the force. And it is equal to minus 52 degrees. And you say that this, I expect that you said that this vector will be in the quadrant number 2. So we will use 180 as a reference, or you can do it from the beginning and have the equation something like this: 180 plus inverse tangent of the y component. In this case, it will be replaced by summatory of the y component of the force and summatory of the x component of the force. 72.1 divided by minus 53.3. And the answer should be 128 degrees. And this is the result.